Hi, my name is Nada Mustafa, and this is a 3D model of reverse transcriptase PCR, in which DNA is made by reverse transcribing RNA, and then it is used to test for the COVID-19 virus. So firstly, there will be a nasopharyngeal swab done collecting a sample from the patient. And okay, so this is a so this represents the COVID-19 virus, and it is an RNA virus, so we will use reverse transcriptase PCR instead of the normal PCR process. So the RNA is extracted from the sample, and then it is added to the solution with the reverse transcriptase enzyme, the nucleotide, and the primer. So the sample is then heated and quickly cooled, and then the primer binds to the RNA. So here we have a more close-up version of the model. So this is RNA, and here is the primer that binds to the RNA, and then the reverse transcriptase enzyme synthesizes a cDNA strand, allowing the nucleotides to attach to the RNA, which then makes a DNA strand. So now this new DNA can be used in the PCR process. So this new DNA goes through denaturation, where it is heated, and this breaks the bonds between the DNA, making it have two separate strands. So next is the annealing process, where the sample is cooled, allowing the complementary primers to bond to their complementary DNA, like so. Okay, and then there are DNA primers with probes on them, and these light up, allowing the DNA to be read. These represent the probes. So then lastly is the extension process, where the sample is reheated, allowing Taq polymerase to attach to the primers, and it grabs the free nucleotides, making this new DNA strand. The same for this one, and grabs the nucleotides, making this other DNA strand. So then PCR is repeated many times, and each time the amount of DNA exponentially increases until there is enough DNA to be analyzed. So if the virus is present, the probes send a signal, meaning the test is positive, and it means the patient has COVID-19.